let's review all the sections that we've covered so far with factoring. So the directions ask us to factor completely. So remember, when we are asked to factor completely, first and foremost, it is going to be crucial that we always look for a GCF. So no matter what, always look for a GCF first. Okay, that's crucial. So in problem number 1, it says x squared plus 9x plus 8. So if I'm looking for a GCF, that means I'm looking for a number that all of them have in common or a variable that they all have in common. I see that there is technically a 1 in front of that x squared. So remember, when there's a 1 in front, that means that the only number that they will all have in common is the number 1. And the number 1, if I factor that out, will not change the problem. So doesn't look like there's a number that I can take out of all those terms. So then I move on to variables. Well, I have an x squared, an x, and then I just have a number. So because they don't all have a variable in common, there is no GCF. So we looked, there just isn't one. So then the next thing to look at is the fact that because there is just a 1 in front of the x squared, we are going to be thinking about numbers that multiply to the last number but add to the number in the middle. Okay, so if I'm looking for numbers that multiply to the number 8 but add to the number 9, well, there's a couple of ways to multiply to 8. 4 times 2 multiplies to 8. But if I add those two numbers, that's only going to add up to 6. That's not the number that I need it to add up to. So we can always multiply 1 times that number. So 8 times 1 definitely multiplies to 8. And notice that 8 plus 1 is going to get us the number that we want. So 8 and 1 are the numbers that we need to focus on. When we factor, we want to have two things being multiplied together. Because there was just a 1x squared to start us off, that means that we need to start each of our parentheses with an x. The numbers that we got to multiply to 8 but add to 9 are the numbers that are going to fill out the rest of our binomials. Both of those numbers are positive. So one of my parentheses needs to have a positive 8, and one of them needs to have a positive 1. Now, if you flip it around and say x plus 1 times x plus 8, that is perfectly fine as well. So this is my answer. If I look at the second one, once again, very first step is to look for a GCF first. I see that they all have a number, something other than 1. I see that 2 is the smallest number. Well, can I multiply 2 times something to get 8? The answer is yes. 2 times 4 multiplies to 8. Can I multiply 2 times something to get 6? The answer once again is yes. 2 times 3 is going to get me 6. So notice that every single one of those have a number in common. That's going to be a GCF. I also want to look for variables. So the first two terms have x's, but if I look at the last term, it's just a number. So there's no variable in common, so the only thing that gets factored out is a 2. So in 2x squared, if I took out the 2, that means we're left with x squared. I'm going to bring down that subtraction sign. I took out the 2, which means I'm still left with the 4, since 2 times 4 got us 8, and there was an x with that 8. I'm going to bring down the addition sign. I know that 6 was 2 times 3, and we took out the 2, which means we're still left with the 3. So by taking out that GCF, I now have a 1 in front of my x squared term. So that kind of takes me back to the first example that we just did. When I have a 1 in front of the x squared, that means that I want to keep trying to factor. I'm looking for numbers now that are going to multiply to 3, but that are going to add to negative 4. And because it's going to multiply to this positive 3, but it's going to add to a negative 4, we have to think about this. There's two different ways to multiply to a positive. We can multiply, and the nice thing about 3 is that the only way to multiply to 3 is 3 times 1. So I can try 3 and 1. And when I add those together, I'm going to get positive 4. So while it's super close to the number, I really want negative 4. So positive 4 doesn't work. The other way to multiply to 3 would be negative 3 times negative 1. A negative times a negative is going to give me a positive. And so when I add those two numbers together, I'm going to get the negative 4 that I'm looking for. So that means that negative 3 and negative 1 are going to be a part of my final factored answer. So I have to keep that GCF, and then now I'm going to be able to take that trinomial and break it up into two binomials being multiplied together. Because what I had in parentheses, that x squared had a positive 1 in front, that means I start each of those with an x. We just determined that a negative 3 and a negative 1 multiplied to positive 3 but add to negative 4. So 2 times x minus 3 times x minus 1 would be my final factored answer. Let's look at two more examples. We've got 6x to the third minus 24x. Once again, I'm looking first for a GCF. 6 is smaller than 24. So let's see if I can multiply 6 times something to get 24. And the answer is yes. 6 times 4 is 24. So they both have a number that I get to take out as a GCF. Now I want to look to see, hey, those two terms actually have some x's in common as well. The first x says x to the third power. The second term has an x to the first power. Remember, when you're looking at your variables, you have to take the exponent that is smaller. 1 is smaller than 3. So that means just an x is going to be a part of that GCF. So I took out the 6 and I took out one x in the 6x to the third. That's going to leave you with two x's left over, so x squared. I'm going to bring down that subtraction sign. 6 times 4 was 24. I took out the 6 as a GCF. That means I'm still left with a 4. The x was also taken out, so there are no more variables. If you look at what I have in parentheses, x squared minus 4, well, that means that 4 is a perfect square. We have a difference of two squares. So another way you can think about this is that this is x squared plus 0x minus 4. So because there's technically a 1 in front of the x squared, I want to find numbers that multiply to the last number but add to the number in the middle. And so if I want to find numbers that multiply to negative 4 but add to 0, if it has to add to 0, that means we want the same number but opposite signs. Well, negative 2 and positive 2 multiply to negative 4, and when I add those two numbers, there is my 0. So those numbers are going to be a part of my new factored answer. The GCF of 6x needs to be there, but now we get to create two more terms being multiplied together. So I get to start my terms off with an x and an x. One of them has to have a negative 2, and one of them has to have a positive 2. And this whole thing would be my final answer. The last example we look at here is 5x to the third minus 15x squared plus x minus 3. So we have four terms, but just like everything else, we have to look for a GCF. So the moment I'm scanning, I see that this x has a 1, which means that moment that there's a 1, I'm not going to have a number that I can factor out of all of them. So then I look to see if they all have a variable. The 3 at the end does not have a variable. So I checked all four terms, but there is no GCF. But because I said there are four terms, that means that we want to think about factor by grouping. I want to group the first two terms, and I want to group the last two terms, and I want an addition sign breaking them up, which luckily I have. So now I want to start trying to factor out a GCF from each parenthesis. 5x to the third minus 15x squared. Well, 5 is smaller than 15. Can I multiply 5 times something to get 15? And the answer is yes. 5 times 3. So they both have a 5 in common, so I know that a 5 is going to be factored out. Both of those terms also have some x's. Remember, I want to take the smaller exponent. That's what they have in common. So between an x to the third and an x squared is what they have in common. So that means that's my GCF of the first parenthesis. Let's write what's left over. Well, 5x to the third. I took out the 5 and I took out 2 x's. That means I'm still left with an x. I'm going to bring down that subtraction sign. 15 was 5 times 3. The 5 got moved out, which means I'm still left with a 3. The x squared also got moved out, so there are no more x's in the parenthesis. I'm going to bring down that addition sign. I see x minus 3 in parentheses. Well, x minus 3, there's no number or variable that they have in common. But I still have to put something outside of the parentheses. Well, what do I put outside of the parentheses that doesn't change it? I put the number 1. So then I'll still have that x minus 3. And remember, when we factor by grouping, I need to have the same thing left over in parentheses. So then that's going to be almost my final answer. But if I'm factoring, I never want an addition sign breaking them up. I always want it to be multiplication. So remember what they had in common, which was x minus 3, that is always going to be one of my parentheses. Whatever I factored out as the GCF, that is always going to be the second parenthesis. And so I am not going to be able to factor any further. This would be my final answer.